Yeah, thanks again. The title is A Characterization for Optimal Bundling of Products with Non-Additive Values. And let me sort of motivate with a problem that we know is a little less general than bundling. Let's motivate with the problem of product line pricing. And this is something that I teach to my MBAs. Imagine that Apple is thinking of how many versions of a product, of a smartphone, to put on the market. And imagine that it doesn't really cost Apple any more to make a phone with 1 terabyte of memory compared to 128 gigabytes, okay? And we know that everybody prefers 1 terabyte over 128 gigabytes. So we have 2 products. One of them everybody prefers, and it's no more costly to make. Why not just make that? Okay, so that's the question that I asked. And we know from the economics literature that sometimes you want to do that in order to be able to do second-degree price discrimination. To charge more for the 1 terabyte version in order to charge more to less price-sensitive customers. So the problem is that when do we do this? When do we do second-degree price discrimination in product line pricing? And when do we avoid it by only putting the best version of the product on the market? Okay? And as I said, the problem of bundling is more general than that, but I find this a better context to motivate what we are interested in here. All right? So with that said, let me briefly tell you what I'm going to do in this talk. I'm going to give you necessary and sufficient conditions for when pure bundling, when not doing price discrimination, is optimal. And of course, this product line pricing is going to be our running example and is one of the reasons why this problem is important. All right? And then I'm going to talk about interpretation based on heterogeneity in substitution patterns and how that correlates with price sensitivity. And if I have time, I'm going to argue that this is very important for future empirical research. Nothing empirical in this paper, okay? But I think the interpretation is important for empirical work. All right. So let me overview the results right off the bat. We have 2 main assumptions on preferences. First off, actually, I need to emphasize that we're looking at a monopolist selling multiple products, so no competition. So we have 2 main assumptions. One is monotonicity of preferences. To see what this means, let's go back to our example. If I have a higher willingness to pay than Rod does for the 1 terabyte version, it means I also have a higher willingness to pay than he does for any other version. In some sense, customers can be ranked roughly based on their price sensitivities. All right? So that's monotonicity, and then we have single peak profits. And I show that with these 2 assumptions in place, the problem of whether or not you want a pure bundle admits a very simple characterization. It turns out the pure bundling is optimal if and only if the grand bundle or the full bundle, if sold alone and priced optimally, simply sells more than if you had any other bundle and sold it alone and priced it optimally. So in more simple terms, pure bundling is optimal if and only if it helps sell more. Okay? About the interpretation, I'm going to be brief here, but sort of more detailed later on in the presentation. Bundling, turns out bundling is suboptimal if higher willingness to pay customers perceive a higher degree of complementarity or a lower degree of substitutability among products relative to lower willingness to pay customers. And I hope here it's already kind of clear why this interpretation matches up with what we had in the previous slide. In some sense, if higher willingness to pay customers see a higher degree of complementarity, namely if they care more about memory in the running example, you want to charge for memory in order to charge them. That's the basic idea. And if that opportunity is not there, you do not really go for this strategy and put the best product on the market. Okay?
Can I ask a question?
Of course.
So if there is a subset of product that is priced optimally is better than all other bundles, but it's not the ground bundle, can I still say that it's going to be optimal?
What do you mean by better than?
In terms of expected revenue?
So this results says something about only how much you sell.
Oh, how much you sell?
If it sells more.
Okay, I see.
Because if it's about better, then it's kind of not a result anymore. It's just the
If I replace the ground bundle with just some subset of products, can I say the same thing?
No. It's only about the grand bundle. I mean, I wish we could say that because that would help us a lot with a more general characterization, but unfortunately, I don't believe that's true.
Sorry,
If it's about heterogeneity and complementarities. If less price-sensitive customers see a higher degree of complementarity, you want to separate the products. You want to charge for that piece in order to charge more to them. Okay? Okay, so briefly on the literature, most of the literature on bundling assumes additive values. It assumes that when I have product A, it doesn't really change how much I'm willing to pay for product B, okay? So I would say my contribution here is to relax that. I'm not saying I'm relaxing that and really not making any further assumption than any of these papers does. It's just about complementarity. I'm relaxing that, but of course, putting in some other assumptions, okay? And the second piece of the literature on bundling has to do with non-additive values. And I would say my contribution to that is if and only if conditions, okay? I provide a characterization with if and only if conditions on when pure bundling is optimal. And I would say the assumptions that I have are different than the papers here. The only paper compared to which my assumptions are stronger, strictly, is a paper by Nima and Jason. The other ones, my assumptions are not necessarily stronger, but different. Okay? So that's about the literature. Let me jump right into the model. As I said, we have a monopolist, sells n products indexed 1 through n. Each bundle is denoted B. It is a subset of the set of all of the products. The set of all bundles is denoted script B. And we also have stochastic bundles defined the way you would expect them to be defined, right? The grand bundle is denoted B bar. It is the set of all of the products. And then we have a unit mass of types T with a probability distribution with a positive density. Valuations are denoted V of B and T. It means the willingness to pay by type T for bundle B. And without loss, assume that all types have an exact 0 willingness to pay for the empty bundle. We have marginal costs for each of the products. The marginal cost for a bundle is the sum of the marginal cost of its components. The marginal cost for a stochastic bundle is also defined in the way you would expect it. About selling mechanisms, each selling mechanism has 2 components, an allocation rule and a pricing rule. Again, we know what they are. I'm not going to explain any further. And we also know what IC and IR are, okay? So with that, let me define the profit and optimal strategy. The profit is easily defined, the expectation over price minus marginal cost. And the optimal strategy is just, you have to find the pair of allocation and prices that would maximize the expected profit, of course, subject to incentive compatibility and individual rationality, right? So let me give you a couple of further pieces of notation before getting to the assumptions and the theorem. We have the simple piece of notation pi of B and P, similar to the notation for the profit function, but here B is only one bundle. It's not an allocation rule, it's just one bundle. And P is not a pricing rule, it's just a real number. All I really mean to say here is that pi of B and P is the profit that you make when you only sell B and price at P, okay? And a couple of notations on pre-endowment. What I mean by that is, imagine there are disjoint bundles B and B prime. If everybody's endowed with B prime, what would happen? For example, with everybody being endowed by B prime, the willingness to pay by any type T for bundle B would be this object, V of B union B prime minus V of B prime, right? And we have a notation for it. I denote it like this, all right? And a similar thing for the profit function. Pi of B and P given B prime is the profit that you would make if you only sold B and priced it at P when everybody has B prime, okay? So these are the notations. Let me now go and start talking about the formal versions of the assumptions and the theorem and everything. Monotonicity is simple. It says fix any B. Both V of B and T and V of B and T given B complement are strictly increasing in the valuation for the grand bundle. Again, let's go back to the example. If I have a higher willingness to pay than Nima does for the 1 terabyte version of the phone, It means I'm also going to have a higher willingness to pay than he does for other versions of the phone, and I'm going to have a higher willingness to pay than he does for upgrading from any version to the 1 terabyte version. Okay, so that's monotonicity. And quasi-concavity says, if you sell only bundle B and price at P, the profit is going to peak only once in that price, whether nobody's endowed with anything before or everybody's endowed with B complement. Okay? So these are the assumptions. Let me give you 2 definitions, which are the sort of objects that the main theorem is going to connect together. The first definition is the optimal quantity sold of bundle B. And by that, first of all, I denoted D star of B. And by that, I mean the total demand for B if you only sold B and priced it optimally. Okay? So that's the optimal quantity sold. The second definition is pure bundling. When do we call a mechanism yes? Oh, OK. Because it was similar to the first time you asked the question. Yeah. All right. OK. OK, we call it mechanism pure bundling if it assigns to each type either the empty bundle or the grand bundle. And the main theorem basically connects these 2 together. And it says under the assumptions 1 and 2, monotonicity and quasi-concavity, the optimal strategy is pure bundling if and only if the optimal quantity sold of the grand bundle is larger than that for any other bundle. So pure bundling is optimal if and only if it helps sell more. I'm going to skip the proof, but I want to say something about the proof. The original proof that I had for this was kind of line-winded, but I had this interesting experience that a referee suggested an alternative proof that is easier and more intuitive. It really helped with the intuition, although I'm not going to give that intuition today in the interest of time, so that the journal actually, upon his consent, discloses his name, so I would be able to thank him in the paper. But interestingly enough, he's also here. He's going to present after me, so I'm going to thank Frank Yang for his more intuitive alternative proof. All right. So with that being said, let me very briefly discuss some points about the assumptions. Monotonicity basically makes the types one-dimensional. I hope that's clear. And that's a strong assumption. But what I want to emphasize is that it's kind of common in the literature. If you think about the single crossing condition, that is actually stronger than my monotonicity assumption here. And by the way, note that types can rank products differently. Monotonicity does not preclude that. Quasi-concavity is also kind of common. I'm not going to talk more about it. Some other notes. As I mentioned before, this is non-additive values, so it puts really no restriction on complementarity and substitution patterns. Okay? Products could be complements, substitutes, complement from the perspective of some, but substitutes from the perspective of others. Anything goes. Yeah, and I have arbitrarily many products. Many papers on non-additive values have only 2 products. And also, one direction of the proof does not require linear cost functions. So the marginal cost could also be different, and still, at least that direction of the result would go through. All right. So the interpretation, I'm glad I have some time to talk about it. This first time appeared in the paper by Nima and Jason, but a version of it also really fits well with this paper. So I'm going to try and sort of connect this result that I have to the intuition about covariation between complementarity and price sensitivity. For the sake of this intuition, imagine marginal costs are 0. In that sense, in that case, what would it mean for the optimal, for the grand bundle to sell more than all other bundles? It basically means if you rank the types descendingly and you sort of go through them, you're going to hit the -1 elasticity point for the grand bundle later than you do for any other bundle. In particular, later than you do for any B and B complement. So the value of the grand bundle dwindles less quickly than the values of its components. This can only be the case if people who have lower valuations for those components see a higher degree of complementarity or a lower degree of substitutability. Okay? Let me, how much do I have on?
You have 1 minute, but you can consume the question.
All right, I guess I'm going to skip this actually. OK, so let me summarize. I provided necessary and sufficient conditions for pure bundling. I said pure bundling is optimal if and only if it helps sell more. The main assumptions, aside from the sort of background assumption of monopoly, were monotonicity and single peak profits. The interpretation was based on the variation in complementarity substitution patterns and how does that covary with price sensitivity. And there's something that I did not really provide here, nor in the submitted paper actually, but it's in a working paper on my website, testing the relevance of this using simulation, which I'm going to talk about in the next slide about future research. On the theory side, I think the clearest sort of next step would be multi-dimensional type spaces. Can we have a model in which three things are in place? Non-additive values, multi-dimensional type spaces, and an if and only if conditions? I think this is a tough question, but hopefully someone can answer that. On the empirical end, I think the intuition, in particular the intuition here, is very relevant for how we build empirical frameworks for second-degree price discrimination or for bundling. How do we advise actual firms out there, for example, Apple, whether it's a good idea to only sell the best version or create a product line? And I think for that, we need an empirical model of demand in which the joint distribution of price sensitivity and complementarity is modeled as flexibly as possible and is identified using as exogenous variation as possible. So this is what I'm going to try to do next in a different paper that we're currently working on. But I think these are sort of, at least to me, the most interesting future directions for the theory and the empirical components of this problem. Thank you so much.
We have time for questions.
Yes?
How would competition affect these results?
Okay.
Can you repeat the question for Gather?
So the question is, how would competition affect this result? I don't have a very good answer. The only thing I can give you is my best guess. My best guess is it would affect these results to the extent that it would affect the complementarity and substitution that people effectively see across products. But that's my best guess. If there are other aspects, I cannot really, form a clear thought on those right now. I think it's a difficult question and an important one.